In this tutorial, we're going to talk about covalent bonding in minerals. And the mineral that we're going to look at for covalent bonding is a diamond. As we already know, diamonds are one of the few native elements. It is a non-metallic mineral, but it's made only of carbon, which is represented by a C. And carbon has 6 protons inside its nucleus, and those are going to be balanced by 6 electrons in the valence shells. What we want to do is actually set up and get an idea for how these atoms look. So if we were to start by making one carbon, we'll write 6p plus for the nucleus, so we know that there are 6 protons in there. The very first valence shell is going to have 2 electrons in it, so it's filled to capacity. And the electrons will be shown in yellow dots. In the second valence shell, we're going to have the rest of the electrons, and we're going to keep filling it until we get a total of 6 electrons. Okay. Now in this case, the carbon has its outermost shell is halfway filled, so it doesn't want to get rid of its electrons because it just needs to get 4 more. Okay. So what it's going to do is going to try to go in and find some electrons that it can get. And what we actually see happening with carbon is that it ends up becoming very good friends with other carbon atoms. So we're just going to draw another carbon that looks the same. It has 2 electrons in the innermost shell, and it's going to have 4 electrons in the second valence shell. So now what's going to happen? Both of these atoms don't want to get rid of any of their electrons, but they are going to become really good friends. They're actually going to merge together. And it's too bad I didn't draw this closer. They're going to merge so that their outermost valence shells overlap, and they're going to share, I'll draw this with pink, these 2 electrons. Okay, so they're each bringing 1 electron to the friendship, and they're both going to hold on tight to that. And what ends up continuing to happen with diamonds is that all of these carbons end up overlapping with 4 other carbon atoms with these covalent bonds, these shared pairs of electrons. So I'll draw at least 1 more carbon atom down here at the bottom. There's our nucleus, our first valence shell, and then I'll draw this close enough that we can visualize the overlap. Okay, so we have our shared pair right at this location. Okay, so once we look at diamonds, we have all 100% covalent bonding on all of the different sides. That's going to create a very strong mineral. In fact, diamonds are the hardest mineral that we have at 10 on most hardness scale, so covalent bonds tend to be very strong. You might be wondering, well, why is it any stronger than an ionic bond? And just remember that both of these atoms need these 2 electrons. Okay? The best way to think about it is to imagine 2 people going scuba diving, and they're underneath the water, and one person's air tank goes out. Okay? So now you have 2 people underwater, and there's only 1 tank of air. Both of those people are going to hold on together, and they're going to share that oxygen back and forth, just like these 2 atoms are sharing these electrons. They can't let go, or else they're going to be in pretty big trouble. So what's happening with the these carbons, they both want them so bad they're going to hold on tight, and that creates these very strong covalent bonds.